Hi everyone, this is question number 16 in chapter 2. So we are given the function fx equals to ax cubed minus bx squared plus 9x plus 5, where a and b are positive, greater than 0. So we need to show that the first derivative of function f is always positive for all the values of x when b squared is less than 27a. Now, so what do? Since they want us to show that the f prime x is always positive, let's differentiate the function f first. So from the fx equals to ax cubed minus bx squared plus 9x plus 5, we got our f prime x to be 3ax squared minus 2bx and then plus 9. Okay, now how do we prove that this function is always positive? Now, there are two ways. It's either we use we write in terms of the vertex form. That means we're going to complete the square first, or we use the concept whereby when it is always positive, there is no root. Therefore, b squared minus 4ac is less than 0. Okay, let's try to use these two methods. So we have first method, complete the square. So to complete the square, you got to look at the term that contain the x and then make sure the x squared is always positive 1 as its coefficient. So let's factorize the 3a. So left with just x squared minus 2b over 3ax. Now we only involve the terms that contain the x. The constant, just leave it alone. So double check when we multiply in, I get back 3ax squared and then minus 2bx. So the next step will be start to complete the square. The rest we're not going to use, so we copy. So when we complete the square, this will be the framework. Okay, the first term we divide by x. Then the second term we divide by 2x. So 2 and x get away. So we're left with b over 3a. And then always minus the square of the second term. So minus b squared over 9a squared. So once we have done, we open up the square bracket. So we have 3a x minus b over 3a squared. And then bring the 3a into the second term. So we will have minus b squared over 3a. We have to factorize the 3a with the 9a squared. So plus 9. Okay, so we have already written this in the vertex form. And for this function, when it is a quadratic function, that it is always positive is when it will never, okay, we don't need this, we don't need the y-axis. This is the x-axis. All right, now since a is always positive, so it must be a smiling face graph. So the graph can never touch the x-axis. That means our vertex, the y-coordinates, will always be greater than 0. That means this part is actually the y-coordinates for our minimum point. So negative b squared over 3a plus 9, it is always greater than 0. Okay, therefore, let's rearrange. So we have b squared over 3a. This one bring there. So now the sharp point is facing the b squared over 3a less than 9. And therefore b squared less than, bring this up, 27a. So we have just shown. Okay, so this is using the vertex form to prove that f prime x is always positive. Another way is, all right, this is the alternative, as I mentioned, okay, or to prove that f prime x is always positive. When you say it's always positive, that means the whole graph does not intersect. Again, we use this diagram. The graph will never intersect the x-axis, therefore there is no root. Okay, so f prime x, always positive when there is no roots. There is no roots. Okay, so when there's no roots, that means the b squared minus 4ac is less than 0. The ABC here is actually the coefficient for our x squared, okay, and the coefficient for our x and also the c. So the b here is negative 2b squared minus 4. The a is 3a. The c is 9. Less than 0. So let's expand this. So we have 4b squared minus 4 times 27a. I'm not going to multiply the 4 in because I see 4 there. So I've divided 4 on both sides. I have b squared minus 27a less than 0. Therefore, b squared is less than 27a. Again, we have just shown. Okay. So that's it for question number 16.